your hands too much. I'm trying to avoid touching it. You can use a cloth if you want as well. If you touch it with your hands, then the ink or the oil from your hands will erode away the copper eventually, which means that your board won't last as long. It's not going to do it immediately, but you want to try to avoid touching as much as you can. It's kind of hard when you have this and you're soldering, but okay, anyway, you fixture it down, press V, it'll go back to 0, 0, 0. And then you move these two numbers, X and Y, which is the 0 home. Not the Z, but X and Y 0 home. So let's say this one is like 50, 100. So it'll turn the spindle on and it'll move. And you just kind of guess until you get close. Figure out where it is. So now I'm going off. Then you use this button to go down.
What other material can you see on this?
Wax. I mean, anything really. I've milled aluminum and I messed up here and actually I built the substrate, but you can mill. You want a liquid if you're going to mill something harder than copper. So I was like putting lubricant on it.
Okay.
But we'll have wax when we mill out the molds for the casting week. We'll do wax molds,
Okay.
3D surfacing.
What is this 0, 0? Is it the lower left corner?
Lower left, yep. So I'm going to move it to 75. Okay, so I'm generally at the lower left corner. So you want to get pretty close. And if you just hit it, it's going to incrementally go down. And then what you do is you loosen the set screws enough so that the tool falls and it hits the copper. So that now you know the tool is touching the copper. You hold the tool with one finger so it's steady, and then tighten the set screws. So if you don't hold the tool, sometimes the tool rises up as you tighten the set screws. So you hold it there so it stays down. You rotate the set screws. And then both sets, there's 2 set screws and both of them need to be tight. And this thing gets stuck. Okay, so you make sure it's tight. You don't have to over tighten it. Just tighten it enough till the thing stops rotating. It doesn't have to be super, super tight. It's not going to fall out. Just all the way until it stops moving. This thing quickly gets worn out if you over tighten it, so then we have to replace this, and eventually we have to replace the set screws. So just be careful on that. Basically, if the bit is touching the ground, you've held it down and you've tightened them, then you're fine, and it should be good. If your board is level and the bit is tightened, then it shouldn't break. So now we know we're at Z0 and we're at X and Y0. The speed and the jog should be ready. So other than that,
What is the lower left of the image?
so it's going to cut it in this orientation, but it will cut it over here, and it's big enough, the board is big enough in that orientation to cut it.
Oh, it's super small. So
Yeah,
it's,
yeah,
okay.
it's that big.
Okay.
So I
So
can
this
make
big.
RML.
Yeah.
And I think I have it. So we send it moves over, and it starts milling out the copper. So you should watch it for the first few seconds, because you want to see along your board if it's even. Because right now the negative Z is 0.1 millimeters. So sometimes if your board is not perfectly level, in the back, it's not going to cut all the way through the copper, and it'll be just a little skim. So you can make that like 0.12. You can bump that up a little bit. Or you could try to make sure your board is completely level.
So can you post it and then change the depth?
No. So that's a case where the job is stuck in the machine. So I can pause it, and when I hit view, it'll keep running. But if you want to change it, the job is stuck in the machine. And it looks like we're fine on the depth here. You can see that all the copper is cut all the way through.
So which one is pause again?
View. And then when I hit view again, it'll go back. and keep cutting. So this is what would happen normally, even if you tried to change something. Well, so you have to close out of all this, run the terminal, kill the job, reset it, and cross your fingers that it's out, or else you'll have a headache and keep trying to do that. Eventually you'll get it out. Yeah.
So this is the same thing, right?
Yeah.
Wow,
So it looks like everything is running well. Looks like it's deep enough. It looks like it's even across. The bit hasn't broken. And so now we just wait. It takes, I don't know, 20 minutes or so to cut it. So I won't make you guys wait here, but essentially when you finish cutting it, you would, it'll stop running. You can turn the machine off, turn it back on again, which will then go back. Do the whole thing, except for instead of the defaults, you choose cut out the board, which will then change it, and you replace the bit with the 32nd, and that's it. Same zeroing process, same sending process, but all the defaults will be there. The only thing to take note is make sure that your X and Y zeros are at the same, because otherwise you're going to cut your board out in a different spot. Right? So make sure whatever these are, that you remember them for the next time, the final cut. So that's the only thing we need to show about the milling. You just wait. If it happens to be that the modella is totally filled up and you guys can't ever cut and you're waiting forever, you can take these in Photoshop and nest them on a sheet. And you can nest, if you look at a board horizontally, you can nest one vertically and two horizontally. So you can fit 3 on here and send one job that cuts all 3. So it'll speed it up. The downside to that is that you don't each get the experience of doing it. But if you sit here and watch someone or you guys work together, then you should be able to, you can cut out 3 and it'll save a lot of time. You don't have to change the tool, you don't have to wait for it to cut. So you can cut 3 at a time. Okay.